Alright, so today we'll talk about features of a sinusoidal function. The very first question that comes in mind is, what is a sinusoidal function? So a sinusoidal function is basically a function that has smooth and periodic curve, just like these. And it is named after the graph of sine, a sine graph, hence the name sinusoidal. And so our lesson about its features. So what are the features that were included? The very first feature is the midline, which is right here. The midline is basically where the very middle line between the maximum value, right here, maximum value, and the minimum value, which is right here, the minimum value, the very middle point. So the distance between the midline, the midpoint, the midline to the maximum and to the minimum is called the amplitude. For the amplitude, the spaces between the top and the bottom should be the same because of the midline. The midline should be in the middle. Alright, so right now we'll talk about the period of a sinusoidal function. So the period of a sinusoidal function is how much change in x would need for it to repeat back to the same point. So for example, right here, you start at this point, so you need to see how much change in x would bring you back to the same point, which is right here. The space between these two would be called the period. Alright, so let's just put this into action. Alright, so this would bring us to our very first example. We have a graph right here. We have a graph right here. And we have the feature that we need to identify. Right, let's start with the midline, which is the easiest thing to do. The very first thing we need to identify is the maximum and minimum value of the graph. So right here, the maximum value of the graph, which is at 1, 1. And the minimum value of the graph is at 4, -5. Alright, to find the midpoint, since it's a horizontal line crossing the x-axis, which we will use the 2x value. We'll add them together, so 1 plus 5 will give us -1 plus 5 plus -5, which equals negative. Alright, so with the maximum and the minimum value, we can just simply count the amount of spaces to get from the maximum point to the midline and from the minimum point to the midline. Now let's count, alright? We can start 1, 2, 3. That's 3 spaces in total. 1, 2, 3. That's also 3 spaces in total. Right? So the amplitude of this line will be 3 since both the amount of spaces and from x and from the maximum value to the midline, the minimum value to midline is also 3. So the amplitude right here is 3. Right, so now let's just talk about the period of this graph. The period, to begin with the period, we'll find a point on any point where the graph hit the midpoint. I'll choose this point right here. Right, so what we need to do, we need to travel along the graph in order to get back to the same point we started. With the same slope, with the same direction that we were going. We'll be right here, alright? Now, right now, at some point, people might ask, hey, if we hit this point, are we back to the same place on the ones on the midpoint? Are we back to the same spot? But no, no. What we need to do, we need to get there in the same direction. Right here, our slope, we're going up. Right here, we're going down. So this is not in the same direction. So what we need to do, continue to go down, and then we go back up right here. that will be where our period is. So right now, at this point, we will see how much space it took for us to get from this point right here, this point right here, to this point. And right now, we're at about negative 6.5. Negative 6.5, and right here, this is negative 0.5. So the space between negative 6.5 and 0.5 is 6. Well, we'll only take the absolute value, so the period of this will be, so the period here will be 6. And that's our answer. The midline of this graph will be y equal negative 2, amplitude 3, and period is 6. And that concludes my lesson for today.